All right, so the next lesson is on solving a system of linear equations, all right, graphically. Okay, so yeah, so in the first lesson, what we did is we kind of were coming up with these systems based on kind of word problems. And then if you remember from the second part of each example, we were verifying solutions by plugging them in. Right. So now what we're going to do is for this lesson and the next two lessons, or three lessons, next three lessons, we're going to be solving the system. So coming up with those solutions using different methods. Okay, so the first method that we're going to look at is solving them by graphing or graphically. Okay. So first example here, we're going to solve the following linear system. Okay, so again, this is a linear system. The reason it's a system is because we have two equations, right? And it's linear because the highest power of x, highest power of y is 1. So you have 2x plus 3y equals 3, x minus y equals 4. All right, so how are we going to solve this graphically? So basically what we're going to do here is step one. Actually, there's only going to be 2 steps here, but anyways, we're going to graph each line. And then the point of intersection. All right, so if you imagine drawing 2 lines, the point of intersection, or where they intersect, is the solution. All right, that's basically it. All right, so so this is why it's important to kind of recall stuff we learned in the last unit, which was linear functions, right, and how to graph them. We spent a whole bunch of time doing that. So we're going to graph these 2 equations, these 2 lines. All right. So I'm going to label this 1, 2. All right. So for line 1, I have 2x plus 3y equals 3. All right. So this one here, it's kind of in general form. Remember that, right? The only thing is the 3 is over on the other side, which is fine. So whenever it's in this form, there's 2 ways we can graph this line. All right. First way is to isolate the y and then change this to slope-intercept form. However, the other way that we can actually graph this line is to come up with the 2 intercepts, right, and plot those 2 points and then draw the line in, which is the method that I'm going to choose to do with this one. All right. So first one here, if I want to find the x-intercept, basically what we're going to do here is you're going to plug in 0 for y. Right? Well, if I plug in 0 for y here, this variable here, 3 times 0 is 0, 0 plus anything is 0, so it's like it's not even there. So we want to solve 2x is equal to 3, which is a simple enough equation to solve, right? We're just going to divide both sides by 2, and x is going to equal 3 over 2. Now, when it comes to graphing these things, rather than leaving it as a fraction, I'm going to change it to a decimal. It's a little bit easier to understand, right? So the x-intercept in this case is 1.5, which is approximately right here. All right, so I plotted that one. To get the y-intercept, so again, I'm just going to write this back up again. 2x plus 3y equals 3. This time here, to get the y-intercept, I'm going to plug in 0 for x this time, right? So if I plug in 0 here, 2 times 0 is 0, 0 plus anything is itself. So basically, again, I just need to solve this equation here. 3y equals 3. And if I divide both sides by 3, y is going to equal 1. So my y-intercept is at 1 right here. All right. So that gives us 2 points. Yeah. All right, so what I want to do now is just kind of draw this line. Now, I'm freehanding it, but when it comes to graphing these lines, you want to use a ruler, straight edge. All right, but I'm going to do my best here to freehand this. Something like this. All right, so I'm hoping that line looks fairly straight. Yeah, so it's easier, actually, it's better to use a ruler or something with a straight edge. All right, so that's the first line. If I want to graph the second line, I'm just going to slide this down. Okay, so for the second line, so line 2, it's going to do the same thing. All right, so the equation for the second line was x minus y equals 4. All right, so the x-intercept, yeah, that's when y is 0. So if that term goes away, it's just basically, right, or it's already solved for. X equals 4. And then to get the y-intercept, that's where you get an x minus y equals 4. If I plug in 0 for x, you get negative y equals 4. All right, so if I divide both sides by -1, y is going to equal -4. Okay, so my x-intercept, use it different. My x-intercept was at 4, and my y-intercept is at -4. All right, so if I draw that line, something like this. Okay, so I've drawn the two lines now. And to get the solution, it's where they intersect. So, all right, so you can see that the point of intersection is right here. All right, so it's the solution is at 1, 2, 3. So x value is 3, my y value is -4. Okay, so that's the answer. So basically what you do is, yeah, you draw the first line, draw the second line, and where they cross, and they can only cross at one point, right? If they're two different lines. That's your solution. All right. Now, even though it didn't ask to do this, what I'm also going to do is I'm just going to verify this is a solution, right? Just a little bit of review from the last lesson. And again, remember, you verify by plugging the solution in for x and y and making sure the left side matches the right for both equations. All right, so let's just quickly do that. So again, the system was 2x. All right, so 2x plus 3y equals 3. All right, so I'm just going to check here. So if I plug in 3 for x, and then I'm going to plug in -1 for y, and we'll see that this is 2 times 3, which is 6. 6 plus 3 times -1, which is -3. So 6 minus 3 equals 3. And 6 minus 3 is 3. Yeah, so we get 3 equals 3. So that one works out for the first equation. And the second equation was x minus y equals 4. And again, just going to plug in 3 for x minus and -1 for y equals 4. All right, so 3 minus -1 is the same as 3 plus 1. It's 4, which means 4 is equal to 4, which works out. All right, so that just verifies it. Okay, so that, yes, so 3 and -3 is the solution. Cool. All right, so the next one here, this time it's kind of this one here. This example is kind of reviewing the stuff we did in the previous lesson, right? Where we're given a word problem and we want to create the system, and then we need to solve it. Right? So to visit a museum, the admission fee is $5 per student, $9 per adult. In 1 hour, 32 people entered the center, and a total of $180 in admission fees was collected. All right, so how many students and how many adults visited the museum during this time? Okay, so a lot of words, I guess, all right, but this is kind of similar to the second example that I did the previous lesson. All right, so first one here, we have the total number of people, which is 32. Okay, so I'm just going to use, actually, I'll use S for students and A for adults, right? So if I take the number of students, add it to the number of adults, that'll be the total number of people, which has got to equal 32. And the second one here, when it comes to revenue or the amount of money being brought in, all right, it was $5 per student, $9 per adult. All right, so to create this one here, 5 times the number of students, give you the amount of money coming in from those students, plus 9 times the number of adults, give you the amount of money brought in by the adults. If I add those two amounts together, that should equal my total, which is 180. Okay. So this is the system that we want to solve. All right, so now, so for this question here, what you'll notice is that we could graph this by hand, but the thing that I also want to show you is basically what we call a graphing program or graphing calculator. All right, so and you can download this onto your phones. It's called Desmos, so I'm just going to open up my web browser. Go to desmos.com, and it should take you to this page. All right, so again, this app, Desmos app, is available either at the Play Store or the iStore or iPhone Store, or whatever you Apple guys call it. So anyways, but if you don't want to download it, you can also visit the web page. All right, so I'm just going to click on the graphing calculator. And what this program does, it actually graphs lines or graphs functions for us. All right, so I'm just going to toggle back to this one here, and all right, so first one here, I have S plus A equals 32. No, error. Okay, so with this graphing calculator, we need to use X and Y. So X plus Y equals 32. And I'm going to punch in the other one here, 5S plus 9A equals 180. All right, so I have to do that again. All right, excellent. All right, so here I've inputted it, and I'm just going to enlarge this screen. You don't see anything on here. Right? Obviously, you don't need to see anything on here because we're kind of zoomed in too far. So what I'm going to do here is zoom out, and oh, here we go. All right, so these are my 2 lines. All right, so the red line is this one. It's been graphed for me, and the blue line is the second line. All right, so to find the solution, it is basically where the 2 lines cross. All right, so the good thing about this thing here is I can just click on this once, and this kind of gray dot will show up. If I click it on again, it'll actually kind of stick with it. It gives me the solution or the point that it crosses. All right, so in this case, the point of intersection here is 27.5. All right, so this is the solution. All right, so if I go back to my Word document here, write that down. All right, the solution was at 27.5. Okay, so and I punched it in for X and Y, but anyways, the first variable here is your S. Second variable is the A. So there was 27 students and 5 adults that visited the museum during that time. Now I can also check or verify. All right, so let's just verify. All right, so again, we verify by plugging these into the equations. All right, so the first one here, 27. Okay, I'm just going to plug it into this one here. S plus A is 32, plus 5 equals 32. Well, 27 plus 5 is 32, right? This one works. And the second one here, 5S, so 5 times 27 plus 9 times 5. Make sure that equals 180. All right. 5 times 27. I can actually do this in my head, I think. 5 times 27 is 135. And 9 times 5 is 45. And if we add these together, that's 135 plus 45 is 180. Okay, so that's just verifying that it is a solution. All right, so yeah, so for these word problems, when you come up with them, and I make a note of it on your assignment sheet, you can use the Desmos, that program that I just showed you, to graph the lines and find that point of intersection. Cool. All right, guys, so that's the lesson.